It's PLA Jack here, and I'm going to be going over a bit of a ray diagram review for mirrors, but I'm also going to touch on a lot of concepts. So we're going to start off with how to draw an accurate and to scale ray diagram for mirrors. This is going to be a good place to start if you're really struggling with them. The 3 principal rays review and some strategies for making the best rays. So a lot of you are making ray diagrams that look like the top one here. And there's a lot of things that can cause that. It's not easy to draw them. I'm naturally pretty sloppy, but I can show you guys some ways that it'll look a little bit more like the bottom one down here. Getting started, you want to draw a circle. This is you don't have to do this full setup, but this is a really good foundation to make things consistent. And you want the principal axis to go straight through the circle. Now, if it's a convex mirror, we're going to erase this side, and then you have a convex mirror, right? This is important because it's going to help your shape. And if it's a concave mirror, you're going to erase this side, and then you're going to have a concave shape. But before you erase, a very important thing to do is draw the center of the circle, C, and the focal point, which is between C and the surface of the mirror. Remember the formula, F equals C divided by 2. One of the first formulas we learned in class. All right, so now that we have that down, we can move on to drawing the object. So drawing the object, we want to think about the scale. So let's say the focal length is 5. We know that this is roughly 3 dots. Using graph paper is definitely helpful. So if we do a few more lengths of 3 dots, and then 1/2 length, because we know distance to object is 12.5, and the height is 7.5, we can kind of ballpark what our dimensions are going to be, and this will just help you keep everything in line. You're not always going to have all the measurements to start, but this is just going to make things a little bit more cohesive, so I would recommend at least doing this a few times so you kind of have a better picture of how things work. Now we're ready to draw the rays. I have an exercise for y'all before we review rays. Try and record the definitions for each of the rays. So which way the ray enters, whether that be parallel through this point or through that point, and then which direction it bounces off. This is how you need to think about the rays, and you can update your definitions after you watch the ray portion. So P ray enter parallel to the principal axis, and it bounces off in line with the focus. You can see that here. It wants to go straight, but it can't because it bounces off. C ray, it goes straight to the center of rotation, but it can't. It bounces straight off, and that's in one line almost. So there's no direction change or anything. The F ray, this is a little bit more complicated than the other two. This one goes to the focus, so it's coming in towards the focus, but it can't make it, and then it bounces off parallel to the principal axis. If you're having trouble getting these mixed up, or see, this is like a gray line here, that's not an extrapolation you want. If you're just getting confused and kind of getting mixed up and not knowing what to do with the rays, you can make flashcards for what the definition of the principal rays are and then how to make the extrapolations, which I'll explain further. All right, so let's draw our first ray. This is the principal ray called the P ray. So we drew it straight on there, and we're bouncing it off. But you don't want to just draw the arrow bouncing off without thinking about it. You want to do a dotted line to see the direction that you're bouncing off at. This is a very important concept. You got to remember that every time you draw something, there's a reason you should be drawing it that way. So keep that in mind. So there's this one, the C ray, going towards the C. But remember, it can't go straight down to the C. It can't actually make it there. There's a dotted line extrapolation, and then the direction bounces off this way. Now it's time for the F ray. Not a very good line. There we go. So you have a pretty clear intersection right there, right? And see, don't draw a line like this, guys. It's the direction that it's bouncing off that you're extrapolating, not the direction it's coming in at. So now we have the image. You can see from this that the image is smaller than the object, so we know it's reduced. It's not down here, so we know it's upright. Additionally, we can see that dotted lines are forming it. These are not actual light rays. These are extrapolations, so it's a virtual image. This is why ray diagrams are so important, because it's going to give you another layer of understanding and confidence in your answers. So it's especially important to just get used to drawing them, so that way you know what's going on in the question beyond just reading a slightly confusing word problem. Another concept I've seen people struggle with is to draw the normal. So a good exercise is to draw a surface and draw some light rays that are coming in at it. So how do you draw a normal? Well, first you need to figure out where it's making contact with the surface, right there, right? So if it's a mirror, it's going to bounce off the surface, and if it's a lens, it's going to refract through the surface. So we're going to make this one example into two examples. This is going to be a mirror example. This is going to be a lens example, or a glass example. So the normal is always going to be perpendicular, which means 90 degrees, right? 90-degree angle, perpendicular to the surface. So think of a tangent line. You can draw a 90-degree angle if that helps, and then that is the normal, this line right here. So since it's a mirror, remember, angle of incidence equals angle of reflection. Boom. It's the one of the first things we learn. It's pretty straightforward, right? So there's that. And you can also use this kind of concept if you forget how to do some of this stuff and forget the definitions. I wouldn't recommend using that regularly, but if you're in a tough spot, that can help. Now, let's say it's in glass. So you got to draw it to see where it hits. All right, so now you know where it's making contact. You know that's where you're going to draw the dotted line, but where do you draw the dotted line? Think about it. What's like the tangent? It's that kind of area. So, dotted line through there. So we know glass is going to be denser than air. So that means we know that our refraction is going to be closer to the normal. It's going to have a tighter angle. See? It goes from a bigger angle here to a smaller angle here. So now that we've covered everything, just remember to take things one step at a time when you're doing problems, and just think about the rules behind each line you draw. Here's an activity for you guys to attempt, and you can come to me with your answer, and I'll tell you if you're right or wrong.